My name is Mike Evans. I'm the first year chemistry laboratory coordinator, so I design, implement, teach, and just generally coordinate the laboratory courses for first year students in chemistry at Georgia Tech. I'm also the College of Sciences liaison to Serve, Learn, Sustain, so I help connect students and faculty with the center, events, funding, that kind of thing, and just generally promote sustainability within the College of Sciences. So within my role as the laboratory coordinator for first year chemistry, I'm interested in giving students a solid foundation for talking about sustainability in chemical terms. It's interesting to me because chemistry as a field and as a discipline and as an industry has a terrible reputation with respect to sustainable communities. And I don't think that's because of chemistry per se. I think it's because large chemical industry has these chronic problems that come with it, where there's a trade-off between providing jobs to a community and environmental health, and that hasn't been managed in the past. So my advice to chemistry as a field would be to make chemistry smaller, essentially. Allow small groups of citizens, or even one person, to perform analysis methods on water that's in their neighborhood. This week, actually, we're running a lab that is called water quality testing, where students bring in their own water samples. I took some students over the weekend to Proctor Creek to collect and analyze some samples, and we got together with Georgia Adopt a Stream to train them on how that works, how to sample properly, how to run the methods properly, interpret the results, and what's normal for the state of Georgia. And that does two things. It teaches students the techniques and analysis methods they can use in their own communities in the future, and it helps Georgia Tech engage with the surrounding communities and hopefully make them more sustainable by giving them back data that's of use to them. So analytical chemistry and monitoring of the environment and consumer products is a big area in this. So chemists will look for abnormal substances, toxins, that kind of thing coming into consumer products or the environment, or even things that are more benign, spikes in concentrations of environmentally important substances like dissolved oxygen or pH, things like this. That's an important element to sustainable communities because it gives communities information about the products that they're bringing into their homes and the environment around their homes and things like this. The other area that chemistry really works hard to promote sustainability in is green chemistry. And the idea there is to take chemical reactions and processes that have traditionally been environmentally unfriendly and converting them into environmentally friendly versions that have a much smaller impact on the surrounding. And so in experiments where we synthesize a material, a so-called desired product, I'll ask students to consider not just their yield of the product with respect to the reactant. You might get a 95% yield, but you should also consider the solvents and the wash liquids and all the other materials that went into that synthesis that were then poured down the drain or put to a waste container and shipped off through environmental health and safety.